Download this code from codegive.com, link in the description below. Certainly. NumPy is a powerful library for numerical computing in Python, and it provides a convenient interface to lapack, linear algebra package, routines for solving linear algebra problems. Lapack is a standard software library for numerical linear algebra that is highly optimized for performance. Overview of lapack in NumPy. Lapack routines are typically accessed through numpy's linear algebra module, numpy.linalg, which provides a high-level interface to various linear algebra operations. Some of the key functionalities include solving linear equations, computing eigenvalues and eigenvectors, performing singular value decomposition, SVD, matrix factorizations, LU, QR, Cholesky, etc. Installation. Before you start, ensure you have NumPy installed. You can install it using pip. Basic lapack operations using NumPy. Let's explore some common lapack functions provided through numpy.linalg. 1. Solving linear equations. To solve a system of linear equations \x equals b \. 2. Eigenvalues and eigenvectors. To compute the eigenvalues and eigenvectors of a matrix. 3. Singular value decomposition, SVD. To perform SVD on a matrix. 4. Matrix factorization, LU, QR, Cholesky. While NumPy does not directly expose functions for LU decomposition, you can use SciPy for that. Here's an example of QR decomposition using NumPy. For Cholesky decomposition, which is suitable for positive definite matrices. Conclusion. NumPy provides a user-friendly interface for performing various linear algebra operations using lapack. The functions demonstrated above cover some of the most common use cases. For more advanced needs, you may want to explore the scipy.linalg module, which offers additional functionalities and more control over lapack routines. Additional resources. NumPy documentation, https://numpy.org/doc/stable. SciPy documentation, https://docs.scipy.org/doc/scipy/reference/lena-lg.html. Feel free to explore these more for detailed functionalities and advanced use cases.